Welcome to the Aspen Plus version 10 video series. This video series serves as an introduction to Aspen Plus for chemical engineering students studying heat transfer. In this video, a heat exchanger flux or HFlux model will be used to find the overall heat transfer coefficient of a counterflow heat exchanger. Water at 75 degrees Celsius will be cooled to 50 degrees Celsius from a cold counterflow of water entering at 20 degrees Celsius and leaving at 66.9 degrees Celsius. The heat transfer area is 20 square meters, and the heat duty from the heat exchanger is 200 joules per second. These results will also be obtained analytically using the log mean temperature difference. After opening a blank simulation, input water into a component ID cell. Then, open the Methods folder and select IAPSW-95 as the method used, which contains the thermodynamic properties of ordinary water. Then, switch to the Simulation tab to bring up the main flowsheet. In the Model palette, go to the Exchangers tab and drag the HFlux block onto the main flowsheet. Now in the Blocks folder, double-click on the B1 folder to specify the HFlux block. The inlet hot and cold streams will be 75 and 20 degrees Celsius respectively, and the outlet hot and cold streams will be 50 degrees Celsius and 66.9 degrees Celsius. Next, specify the duty to 200 joules per second and the area to 20 square meters. Now run the simulation. In the B1 folder, click Results, and the overall heat transfer coefficient from the simulation should be 0.598 joules per second square meter Kelvin. These results can also be obtained analytically using the log mean temperature difference. For a countercurrent heat exchanger, the temperature difference at two ends of the heat exchanger are used to find the log mean temperature difference. For this example, the temperature difference of the inlet hot stream and outlet cold stream, and the outlet hot stream and inlet cold stream, gives a log mean temperature difference of 16.72 Kelvin. Knowing the heat duty of 200 joules per second and 20 square meters, the overall heat transfer coefficient can be solved to be 0.598 joules per second square meter Kelvin. This is the same result from the Aspen simulation. This concludes the first video of the Aspen Plus version 10 video series for heat transfer. Please look out for future Aspen Plus videos for chemical engineering students.